So welcome everybody to this demo on SRE. We call it Site Reliability Engineering and Cloud Performance Engineering in DevOps. So we are coming up with a course with Isha. First of all, let me introduce myself. My name is Roshan Kumar. I have 18 years of experience in IT. I'm currently working as a principal SRE. I have been in various different shoes over my careers. I started my career as a Java developer, and then I've been into performance engineering, Java performance engineering for 6 years, and then I have been into system admin, worked with multiple cloud service providers, AWS, Azure, GCP. I'm a DevOps and SRE consultant, Kubernetes expert. That's background about me, friends. Currently, I'm handling one of um, the giants retail of the world's, where you can think millions of transactions per second is what we are accommodating. So that's background about me. So let me introduce you to this course, friends. So the agenda for today's discussion is be that we'll be starting with a question. I'll ask you one question from all of you. Um, and then we will we'll go over software development and deployment evolution. So how software has developed and deployed over the years, the evolution of development and deployment. We'll go over that. And then we'll talk about the course syllabus, what this course is all about, like how we can be benefited, how it will help your career. We'll talk about that. And then you can ask your Q&A, friends. Mostly we try to finish this session in 1 hour, 50 minutes. But if you have questions, it may extend up to 1 hour, 30 minutes as well. So that's the plan for today's discussion, friends. Okay. So I'll start with a question, friends. So this is the question. I'm going to assume that most of the folks are here for performance engineers. That's what have been the trend over the years. But this question is general. Okay, not just the performance engineers, but in general, anybody who working in IT, like either you are a DevOps engineer or a cloud engineer, cloud admin, or you're into system administration role, or you are into support, uh, right? This question is for you. Okay, let's understand this and let's get a poll. Friends, do you agree that as per the current market trend, right, whatever things are going around us in the software industry, the knowledge of these things are super important. The knowledge of DevOps, what is DevOps, microservices, containers, cloud, right? Do we agree, friends? I would like you can give me yes, no, or not applicable, or no, you don't know. So you can opt for these answers in the chat. Let's hear it from you, friends. Okay, I have started to get this messages and looks like everybody is saying yes. Yes. Dheeraj, Sabha, Vaibhav, Suresh, Nagarajan, Gokula, Krishnan, Mayank, Ramesh, Praveen. Yeah, everybody. Yes, friends, you're right. Satish, like everybody, right? Yes, definitely. I'll show you the next slide. Then you'll understand why it is important today. These four things: DevOps, microservices, containers, and cloud. Why these things are important or relevant in current market trend? You'll understand when I show the next slide, which is the deployment and development evolution. If you look at this slide, friends, you'll understand. If you look at the development process over the years, how we have transitioned from waterfall to DevOps. Like in waterfall, we had a simple approach. That's how we started one of the SDLC model, software development lifecycle models. We started with waterfall. It has a very simple approach. First, complete the development work and then test. A lot of issues happened here. And then we moved to Agile, where we split the software development into multiple phases. We did all the process of SDLC. We did development, testing, performance testing, QA testing, security testing. We did all sorts of testing in every release. We took the feedback from the customer, from our client. We incorporated the feedback, again, developed few more features, again, did all these SDLC, and we call it Agile. There were no problem as a process in such with Agile, but DevOps is all about automation, friends. If I ask you, very simple question, and I want anybody can answer this. You don't require a prerequisite knowledge. If you think rationally, you'll be able to answer. Let's say when developer says the code is ready, let's say I'm the client, developers are working for me, let's say, and they tell me code is ready. What would I want? What do you think you would want for the developers to do with that code? Eventual goal. Let's. What do you think? When the code is ready, what do you want with that code? Testing is one of the phases, Ramesh. Eventual goal is to deploy that to production. That's it, right? That's the main goal. I would like get my code released to the customer, released to my end users as soon as possible. If Flipkart, Amazon has a bug, and if developers has fixed that, what Jeff Bezos or Flipkart owner would want? Get this code available for the customers. That's the end goal. But we don't take a risk. We do all sorts of testing. We do functional testing, automation. It could be automation, performance, security. We did do all sorts of testing, and then we eventually release the code to production. And if you look at this, the lot of time gets spent if things are not automated. When the code is ready and before it goes to production, a lot of time gets spent. DevOps focuses on that. DevOps focuses on how can we streamline the process? How can we automate that process so that it takes lesser time? We are quicker to production. The release is happening swiftly. That's what DevOps focuses on. And that's why these topics are very important. Automation. And it's done through CI/CD pipeline. You might have heard of this term, CI/CD, continuous integration, continuous deployment pipeline. We can use tools like Jenkins, Maven to build this. Now, this is on the development process, SDLC approach as such. But when it comes to the application architecture, friends, earlier there were big monolithic applications. The applications used to be very big. If you look at the application server, let's say you have a 3-tier application. Focus on the application server. You have all the code packaged together, huge dependency of code. One function is calling other functions like modules, different business modules. They are packaged together, you huge dependency. It created a lot of problem. If you would have attended my last this Saturday, one of the workshop, you would understand what I'm talking about. If you don't know about monolithic or microservices, right? I'll just give you a quick recap, friends. I'm not sure if you would have attended or not. I'll give you a quick recap. So what is monolithic, right? What is monolithic and microservices? So focus is on the application. Let's say you have a 3-tier application: web server, app server, database server. Focus is on the app server. When you have a lot of modules, and in each module you have functions written. And when you call the functions from one module to another module, huge dependency of code, we call such application monolithic application. Mono means single, lithic means big, monolithic. So it has a lot of problem. So with one module, one function could bring the entire application down because of dependency. So the best thing is to split it into microservices, right? And that's what's happening in the today's current market trend, friends. It's all about microservices. How can we develop a software, a solution which is microservices in nature. We don't want a lot of code, make the service bulky and a lot of code like monolithic problem. We don't want that. Let's split it. And if you want something to be done from, if you want some information from M2, call the APIs, get call, put call, put call, patch call, right? So like when you go to Make My Trip or Flipkart, right? When you search for source destination, right? I'll just give you this example. Monolithic versus microservices. And a little about the what is REST API calls. So if you go to Make My Trip, friends, I would like to ask you this question. Let's say you put some source destination, some date. Click on search. How do you get the details about different flight carriers? I'm in Make My Trip website. How do I get to know about Air India? How do I know about Akasa Air India or Indigo? How do I know? Do you think Make My Trip owns all the flight carriers?
No,
Right? It doesn't. Do you think Make My Trip has database access of all these flight carriers?
no, not sure, but I am say no.
No, it's not the case, right? It's all about API calls. These flight carriers, they have exposed APIs, get call, post call, and all Make My Trip or other Clear Trip or Flipkart, they do is call the API and get the information. They need to purchase the API. All these Clear Trip or Make My Trip or any other website, they need to purchase the API from these flight carriers so that they can call and they can get the information. It's all about API calls. So similar to that, we need to have a similar strategy, friends, in the case of microservices. When you split the big monolithic applications, which are tightly coupled, huge dependency, when you split this, when you make it independent, when you don't call the functions, if you want to get something done, you will call the APIs. Get call, post call. That's the microservices when we are living in. Let's say, have you ever wondered? Let's say you are in Swiggy, you order some food item, it goes to the third party for the payment gateway, secure gateway. We do the payment again, it comes back to the Swiggy, confirms the order. It's all about API. It's all about API. We scan a code. Let's say you're paying somewhere online. You scan a QR code. You scan it. You scan a QR code, and we get the information. Or you give a number. Let's say you go to online. You give a number, or you give your UPI ID. As soon as you click on submit, you get the message in your mobile. Okay, do you want to make this payment? So it's all about the entire world. If you look at this, it's all about the API call, API communication. Right? So and that's how two services would communicate. And that's the no different in case of microservices. We don't need to have all the code base put together like a monolithic applications to make it work. And that's the entire concept about monolithic versus microservices. That's the next part. So we have been transitioning over the years. Around 1980s, we started with monolithic. Now it's all about microservices, how we develop microservices, how they communicate efficiently. It's all about that. Again, on the deployment and packaging, the server side, from the infrastructure side, we have progressed a lot. Earlier, if we have to deploy some application, it used to be in the physical server. We were wasting a lot of resources. Then there came the virtualization concept around 2000. We could use the same hardware and we could create multiple VMs, VM1, VM2, VM100. We could create multiple VMs. Still, we wanted to more optimize because the VMs were not properly utilized. So what we are doing, we are taking one VM and we are containerizing it. We have concept of Docker and Kubernetes. You might have heard of it. People would be asking in the interviews, what is Kubernetes, auto scaling, how it works, why do we do containerization? You might be hearing this question in the interview, right? So we'll discuss in detail today, not the right day, because I need some discussion, half an hour here to discuss about it. But no, that it's all about resource utilization. Efficient, the goal here is to optimize the cost. The goal here is to optimize the cost through efficient utilization of the resources. We want to utilize the resources better. Tell me, friends, if you have 10 servers in production and overall usage is 20%, do you think it's cost optimized solution? Why can't they have 60%, 70% of the usage? Why can't you manage with 6 servers and have 70% of the utilization? Right? It's all about that, around the same logic. How can we make sure that we utilize the resources of a VM efficiently? Because if you look at the cloud cost, anybody who working in cloud or even in case of on-prem, the maximum cost is involved into EC2, the server, the virtual machines. And if you could optimize the resource utilization, we could optimize the cost. Companies have reported to save up to 80% of the cost when they move to containerization. So like virtualization around 2000 was a technology, was a revolution. Same thing is happening, has happened 8 years back in 2015. We call it containerization. Every company, they are using containerization, Docker, Kubernetes, every company. Even if they have monolithic application, they're trying to containerize. At least they want to utilize the resources. Their work is going on to split monolithic to microservices. That may take time. At least they're getting started. Why can't they deploy monolithic to these containers? Because anyway, if they can get the cost optimization, they could save better and they can utilize those spendings somewhere else. And friends, on the application infrastructure from the data center, earlier, if you have a business idea in 1980s, you have to set up a data center, which is a very costly affair. What is a data center? Like, consider a facility in the outskirt of a city, friends. Like this kind of facility, I would just show you. Most of you would know about these things, but let me just show you if what is a data center. So consider this kind of facility in the outskirt of a city where all the big rooms, halls full of these kind of servers, right? That's called a data center. It's a very costly affair. You have to purchase the land, procure the land, construct the infrastructure, purchase all these hardware, all the server storage. This server storage will generate heat. You have to make sure that heat is optimal there. You need to set up for the cooling mechanism. These servers cannot run out of electricity. You need to make sure you have redundant power supplies. These facilities cannot run out of internet. You need to make sure you have redundant internet providers. Like very costly affair. You need to have recruit people for the security for this facility. You have to keep people, employ people for the maintenance of this hardware. So it's a very costly affair to have a set up a data center around, and that was the situation. But nowadays it's all about cloud. We will use somebody else's data center. We'll pay some amount. Somebody has like AWS, Azure, GCP. They have set up a data centers across the globe. Why can't we just leverage it? We'll pay some amount, monthly rent, like how we stay in rented apartment. Same thing, we'll pay some rent for the servers, for the storage that we use. Like the entire Netflix that you watch, the content front is stored in S3, which is in AWS. S3 is a storage service. The entire Netflix is in AWS. They don't have a data center as such, but they're leveraging it. Their business model is okay with this, right? So it's all about the cloud. So there's no need. If you have a business idea today, if you need some servers, you don't need to set up a data center. You can use the cloud providers and get going. So friends, that is why I put these things in question, that do you think these things are relevant? Yes. Whether you are a performance engineer or an SRE engineer, site reliability engineer, or you are a cloud admin, or you are a cloud engineer or support engineer, DevOps engineers, we have to know this. We have to know this. And this entire course, friends, is designed in such a way that we get up to speed here. This course is not about the Jmeter, right? No, I am expecting if you're from a performance testing background, you would know Jmeter. I'm not going to talk about Jmeter here. Yeah, we do talk about performance engineering, Java performance engineering, and we talk about these things. I call it platform engineering, because if we talk about the platform here, we talk about the automation here, and this is the entire thing about the SRE, and this is the entire course that we have is for the site reliability engineers or for the performance engineers who wants to upgrade themselves, you want to upskill themselves so that they can take better opportunity. Because without this, without just having the knowledge of performance testing, tool will not help here, because along with that you need to know the underlying infrastructure, how to optimize, how to performance tune, infrastructure performance engineering, infrastructure engineering, along with performance tuning the your code perspective. From the application perspective, we need to also understand how can we optimize the performance issues from the infrastructure, and that's where we need to know this, along with automation of the DevOps. So this course is designed for that, friends. So I'll go over the topics that we have in the course, right? Any questions on this slide? Anybody has any question? Want some more details? Please go ahead, friends.
Yeah, Roshan. So you have told about the data centers. Here, let's take an example of AWS. So how many data centers do they have?
Okay,
And
they
do you have
have
any
one.
data?
Yeah, they have 100, more than 100. So to be precise, I can give you a number. If you go to this link, AWS Global Infrastructure, if you go to this link, you would get the exact count, so which is
Yeah,
140. Yeah,
got it. So what's that CloudFront POPs?
these are CDNs, Content Delivery Network.
Okay. Okay, yeah, got it. CloudFront service. Yeah, got it.
These are the CDNs they use for the caching. They can cache things for the better performance.
Yeah, got it.
Okay. Anybody else? Any question on this?
So I have a question.
Go
So
ahead, go ahead.
is SRE is an extension of DevOps?
DevOps engineer, yeah, see, DevOps is a bigger umbrella. Okay. DevOps is a methodology, SDLC model, right? Like how we have waterfall, agile, DevOps. So whatever we are talking about from the approach perspective, see, DevOps is all about how do we go about developing a software. That's the SDLC. So SRE is an added skill that once the software is ready, once you have developed the software, we need to make sure that the software is stable, is available, highly performing in production, secure, and we need to continue to do so. So SRE comes there to make sure that the users, the end users, like let's say if you're using Flipkart, Amazon, like we are the users. So the users have the best of experience from the performance side. From the application availability side, the application should be highly available. From the security side, right? If we store our credit card details, our user data, that's secure, right? So that's where the SRE comes into picture. So that how do we make sure that the customers keep getting the best experience? So that's where the SRE comes in.
In SRE, it will cover like tuning and as well as HOS testing, everything it will cover, Roshan.
That's right, Jayapal. See, it's all about, as I told you, anything to do with the user expectation, user experience, right? So in production, let's say Flipkart is going on. Flipkart, we use Flipkart. Let's say something goes wrong, right?
Yeah, okay.
Uh, let's say they put on sale. Let's say they put on sale, and they were not expecting that much of user load, but something was wrong. So we, as an SRE engineer, we need to understand what we need to troubleshoot issues. We need to understand the root cause, what caused the problem, and we need to make sure it never happens. Or we need to have some automated way of remediation so that if the issue comes, it gets remediated. That's a high level of automation. But to keep it simple, yes, we need to make sure customers keep getting the good experience. Now, we don't, from the good experience, when I say the application should be highly available. So we need to make an architecture in such a way that application is stable or available. So now when it comes to this, like chaos testing, we need to make sure, because in production anything could happen. One server could go down, or one AZ could go down, or one load balancer stop working. In that case, what is the problem? What is the repercussions? What is the cascading effect? To understand that, we need to do a lot of testing. So chaos is one of the testing that we need to perform to understand in the case of unusual event. See, if everything going good, no problem, but we need to be ready with some unusual event, which is not like frequent, right? So we need to be ready with that. In case of disaster recovery, what to do? How to become available, and what time, right? So every company has different SLA. So let's say if I talk about NASDAQ, which is the US exchange, which we do secondary trading, those are like in India, we have NSE, BSC. We cannot afford to have downtime there. As simple as that. So we need to make sure we have enough like sites available, data being replicated across multiple regions, so that even if one region goes down, we can switch the traffic in no time. So depending on the customer, we need to understand the SLA, what could be a tolerable limit, and depending on that, we work towards it. So yes, a lot of scope is there in the SRE, Japan.
So you guys are showing everything in like practically how we can do everything.
Correct. I'll talk about the course. I'll talk about the code, and you'll understand
Okay.
what are we covering here. Okay. Anybody else?
Yeah, like Tanama here, we have separate team for doing the performance testing and security related testing in DevOps, right?
Hmm.
So, and also like the deployment is also happening, and it is also giving the notification, like why it is failing and all. Even AI or AI tools also in use. So, what is the specific role of SREs? Compared to other testers, performance testing and security testing,
Hmm.
what type of work uh,
See,
is done by
correct. Let me answer this question. See, performance engineers, if you see, they mostly work in a non-production environment. We test in QA environment or performance environment or pre-prod environment. See, how much ever we try as a performance engineer to simulate the prod behavior, it's not possible, right? From the data perspective, it's very difficult to imagine or understand all the use cases. Whatever we try, there could be something happening in production which has never been tested. There could be some behavior because we how much ever we try. So one point is that performance engineers, as you mentioned, we do test as in non-production environment. But as an SRE engineer, our responsibility is to make sure production is highly available. If something goes wrong, it will go wrong in production. And that's when the SRE engineers will be called. See, SRE engineers is not going to solve the complete problem, but he has to understand the entire architecture, troubleshoot, narrow down the issue, and bring the right team in place. See, if the issue is with the application code, let's say, SRE engineers is not going to fix that code. Yes, SRE engineer will have the backup plan how to make sure application is highly available. Maybe we can roll back the deployment, right? One of the simple use case, something got deployed, it was missed in testing, and something like, let's say you got the issue in production. The moment the new code went live in production, you start getting 500 status code, non 2xx status code, errors exception in the status code, and you under response time high, you understood that something is wrong. What immediately needs to be done? Or after a couple of hours, it is started to problem or started to happen the issue. What needs to be done immediately? So the rollback is the next step, right? One of the batch, one of the things. Or we can do a blue-green deployment. We can switch the traffic to a healthier cluster. These two options. And then we need to bring the right, first of all, narrow down the issue and bring the right team member to fix the problem. Who is going to take that responsibility? We cannot expect this from a support engineer in production, right? To do this kind of troubleshooting and to narrow down the issue, to understand where the problem lies. You need somebody to take care of this. You drive this, right? You need somebody to take care of this. So those are the SRE engineers. Same thing from a security perspective. We do test, again, the lower environment, QA, performance environment. We do test the security, scan the code. But again, we'll do the same thing in the production environment as well. So that's the basic difference. Working in live issues, how to remediate, how to tackle those issues so that the customers are not impacted. That's where the SRE engineers comes into picture.
So question based on that. So you're saying the test deployment testing, right? The issues happening, right? Those are part of DevOps, right? SRE, my understanding is kind of unpredictable things, right? You predict and you put like a hypothesis and create something, right? That's what SRE is.
See,
It's like
again,
chaos engineering.
right. See, that's what I'm always saying. So chaos is a part of SRE engineer because we need to be ready. SRE engineer, see, deployment till deployment, as I told you, is the responsibility of a DevOps engineer. The code got deployed, running good. Everything is going good. Now, after 2 days, 3 days, some issue started to happen. We need to have right alerting in place so that the issue gets, we catch the issue beforehand, before it becomes a incident or it impacts the customer. So the role starts here. The how we put alerting. How do we alert? How do we set up alerts? Are we doing a proactive alerting or reactive approach of alerting? So the roles and responsibility starts from there. How are we setting up alerts? That's the step number one. Like the problem coming, how the problem would come to know, the SRE engineer would get to know about the problem. So the alerting is one of the very important aspect. And then what to do to remediate the issue. That's the role, so that the customers are not impacted in case of uneventful, like unusual event, which is not common. So alerting, like I would simply put like this way. So alerting is one of the creating dashboards, panels. Alerting is is the responsibility of an SRE engineer in production so that we can capture the right metrics to troubleshoot, to narrow down the issues. Second, we need to be ready of some unusual event, and what to do in that cases. We need to have a proper plan in place. Do we need to do a disaster recovery, or we need to like do a roll back the deployment? It's a blue green deployment. So again, we need to understand the deployment process, like whatever the DevOps engineer is doing, the rollback strategies. How do we make sure, the first thing, that the customers are not impacted? That's the first thing. What to do? And for that, we do a lot of chaos testing. We do purposefully, we stress the system, unnecessary, unusual behavior, because in production, we don't know what would go wrong. So we do chaos testing, chaos engineering. We purposefully fail systems or the components here and there. We test it. right? And the troubleshooting, narrowing down the issue. So these three, along with the automation, because in production, we need to automate a lot of steps, which is for the customers, where the customers need attention or any for the any mundane activity, repetitive task needs to be automated. So the automation, troubleshooting, setting up alerts, dashboards, understanding of deployment strategies, chaos testing are the security we need to understand, right? So if audit purpose, and we need to be aware of this. See, there are security engineers, but as an SRE engineer, we need to be aware of the security things that's happening. So these are the attributes of an SRE engineer or the knowledge points where we need to focus on. Okay, I'll talk about the course.
So we will be focusing on these things mainly, right?
Correct. As I mentioned, yes.
Oh, okay. Okay.
So let me talk about the course, okay? And then you'll understand how we have planned this course. See, the problem the course talks about from the scratch. See, there could be various people who knowing the cloud. Let's say they know the cloud, they know the Kubernetes, Docker, they know what is microservices, they know the automation. So that's a different story. If you know already, if you're looking for the like some next level knowledge, so we are starting from scratch in this course. We are trying to fill the gap of a normal any cloud engineer or a performance engineer, performance tester who is working on, let's say, Jmeter or some other tool, but they don't know how to progress in the career. So this course is designed for that. We take up cloud here from scratch. So let me get to the course link. So this course talks about from scratch. So we don't expect anybody to have cloud knowledge, like from scratch, zero cloud knowledge. It will work. That's what our intention is. We start from scratch. Even if you don't know cloud, yeah, it's covered. That's where we are starting from the scratch. Linux is very important because what I have observed is that, see, 95 to 98% of the deployment happens
Your
in
voice
Linux.
is breaking. Not able to.
Okay, let
Not
me check
coding
with
voice.
others. Is my voice breaking others?
No, it's clear, Roshan.
Jaipal, you are breaking. So I think.
Your voice is not a good question.
Jaipal, you are
Your voice
breaking.
is breaking. Okay.
Okay, let me continue. You would get the recording, Jaipal. So yeah, so let's see what you can hear. So it's from we start from the cloud knowledge, friends. So we take it from scratch. That's the USP. We don't expect you to have a cloud knowledge. It's about the transition. You from a performance tester to a cloud performance tester or engineer. Over the years, I have observed that, see, 98% of the deployment happens on Linux. And I have observed that most of the folks are comfortable with Windows, but not on Linux. And we need to be comfortable with Linux to troubleshoot things, to go over the logs. Because as an SRE engineer or as a performance engineer, right, to trouble whoever who is doing the troubleshooting, going over the logs, we need to be comfortable with Linux. So we have this module where we talk about the Linux. Again, from scratch. We talk about the still self-scripting, and we can also do performance monitoring using these tools, using self-scripting. We talk about that. We talk about the SRE concepts. What is reliability? I use the word reliability, but do we really understand this? Fault tolerance. What is high availability? How do we achieve high availability? What is disaster recovery? How do you do recovery? What all different steps involved in that? Again, the difference between SRE and DevOps engineer, and these terminologies, SLIs, SLOs, SLAs, error budgets, and various other words, MTBF, like a lot of mean time between failures and a lot of other terminologies. How do we do incident management, change management? So we'll talk about that. Again, we talk about the architecture, monolithic versus microservices, and in detailed discussion, the benefits and all. Again, then how do we deploy? Like I would talk about the containerization. So we talk about containerization in detail. We talk about Docker, a container engine. How do we create containers? How do we deploy microservices in the containers? We talk about Kubernetes. How do you auto scale in Kubernetes? How ingress works in Kubernetes? What is services, load balancer, node port, cluster IP? And we take EKS uh, as the example. EKS is the Elastic Kubernetes Service, cloud service. And we demonstrate Kubernetes here. We create the cluster in cloud. And that's what the trend is. Every company they use managed Kubernetes service of cloud. So we'll talk about that. So if you look at this, we are touching base upon everything. We're talking about AWS here. We're talking about Docker and Kubernetes here. And we'll talk about the DevOps here, right? So if you look at the course here, we talk about the DevOps. What is DevOps? How continuous performance testing works in DevOps? How, because as part of CI/CD pipeline, we need, as a performance engineer, we need to also have our job, performance job created in the organizational pipeline. So we talk about this. How do you create performance job, continuous performance testing in DevOps? How Jenkins work with Jmeter? How do we create CI/CD pipeline in Jenkins? We talk about that. Jenkins architecture. How do we create jobs? It's all about the automation here. So Jenkins, I would put as part of automation, CI/CD pipeline. Jenkins integrated Jmeter. Then we talk about gaining resiliency. How do we gain resilience and reliability in AWS using AWS services? We talk about DynamoDB, different databases, relational database, Lambda, right? Load balancing, auto scaling group. We talk about observability in this course. We usually take up the open source tools, Prometheus and Grafana, and Elastic Stack. We talk about those. How do we set up? How do we install? How do we do a dashboards creation for Prometheus and Grafana and Elastic Stack? We talk about Java performance engineering in this course. How do you troubleshoot Java applications, right? JVM architecture, memory management, like how GC algorithm, different various GC algorithm works and related to performance, heap dump, thread dump. We talk about that. We talk about automation here using Terraform and Ansible. This is this course fits. This is what we talk about, and we talk about from scratch. So it looks a lot more. Yes, it is, and it takes this course takes a lot of time to complete. It takes, so as part of this part, we are gonna meet over the weekdays, 3 days a week, Tuesday, Wednesday, and Thursday. We meet for 1.5 hours a day. So you can think 4.5 hours in a week we meet, and this takes about 3 months to complete. This talks about 40 to 45 hours, this course. And that's why, to make it better, what we have done, we love most, so 40 to 45 hours of live sessions. And to make things better, what we have done, we have split into, so because Linux, we're giving as a recorded session. Okay, it's my recorded session. Earlier we used to take it, again, it will get longer. Our session used to go for 4 to 5 months. So we have just made it for 3 months so that it doesn't to get extended. So as soon as you get enrolled, you'll be given access to this 4 hours of Linux sessions. I'll show you how that would look like. So this is what you'll be getting as part of this. So very scratch, very simple, crisp 3.5 hours of Linux part here. Will be given a recorded session, and you can, it's my recording. I leave it to take as part of live session, but just to manage it well, you can ask me any questions from here. And most of the sessions are live. Like as I told you, 45 hours of live sessions. We talk about AWS, and meanwhile, you're expected to go over the Linux part and complete that and ask questions. I'll give you the platform. Where do you practice the Linux commands. So you need a Linux console to practice. We'll get you that, right? And then it's all about the live sessions here. Apart from this, we only give the Java performance engineering, because I know most of you are already have been into Java performance engineering done. So we share this recorded session. Again, it's my recorded session, so that we can spend more time on other things. So this is what you would be getting as part of Java performance engineering. These two are recorded sessions. Apart from that, everything is live. You want to see the live sessions? This is how the live session would look like. I'll be sharing this. My current batch is going on right now. A weekends batch is going on. And this will be the recorded session, like the way we are recording it right now, like demo. This is our demo, and day one will start from tomorrow and we'll continue. And that's how you'll be given all the recordings as and when we'll complete topic. Right. You'll be given access to the entire PPT that I use for the course. This one, the entire PPT. You see, we'll be adding you here to give you access. Here, like you see, a lot of people added, so they are all those are enrolled to the course sometime, right? So we'll be giving you access to this, which you have a lot of PPTs here about about the cloud. This is about the Docker. So if you look at the cloud itself, if I just show you it will have around 150 slides. So a lot of content. We mostly talk about a lot of things here in the cloud. Again, we have a lot of services, a lot of things. We make you prepare like a solution architect. 60% of the course of solution architect we cover. I'll guide you if you are looking for certification. I'll guide you what needs to be done in the cloud part. We talk about Docker, Kubernetes. If you look at the Kubernetes part, again, we would have in detail, we cover 100 slides. It would be having Kubernetes thing. Yeah. So we have a lot of things. If you look at the Linux part, Linux, if you look at the Linux, so although I'll be giving the recording, I have this PPT as well. In the recordings, you will see that I'm referring to this PPT, and you have all sorts of commands. What commands you use for directory navigation, system informations, networking. So you have step-by-step commands given, right? And you'll be practicing it. That's what I have been showing you in the recorded session, which I'll be sharing in the sessions. And you're supposed to practice it and ask me questions. So like a lot of detailed for each of these things. Again, when it comes to the SRE, again, we have databases, cloud databases we cover, the SRE module, the Java performance engineering, which I was talking about. You have PPTs covered where we cover like GC algorithms, JVM architecture, heap dump, thread dump, right? So what all those things, the various kinds of JVMs, JVM architecture, different components, memory managements, all those. So we have everything in the recorded sessions, various GC algorithms that we have, parallel GC, how it works, CMS, G1 GC. So you can see this like detailed discussion about all these things. How do you take heap dump analysis using MAT? How do you check all these things? So everything is there in the course, friends. So this is about the course. I wanted to, along with that, you will have a lot of other documents about the heap, like performance engineering. So yes, that's about the course I wanted to talk about. Any questions about the course, friends, which you want to go in detail?
Yes, so like
Go ahead.
regarding the live sessions you have been mentioning, right? So is it like we'll be having some problem solving sessions as well. Like if any application is got into error, how we are going to debug it, or like how
Yeah.
we are going to because like do we
Sure.
have any something like a sample application which is getting into problem and debugging it, or how we go through?
Okay. See, understand the scope. When we talk about Java performance engineering, yes, we do have some faulty code. Okay, that's
Hi.
different. That's called Java. How do you, because we need to create some memory problem and all. That's on the application side. But
Hi.
on the infrastructure side, we need to understand various things. Because infrastructure side is all about the cloud. So everybody, it's a hands-on session. Okay, hands-on, when I say, I'll be showing you, you would not be doing along with me because that takes a lot of time, but I'll be showing you everything, how to create everything. Like, okay, if I show you, like, if you know about cloud, you would understand, like networking. How do you troubleshoot networking issues? Let's say if you have flow logs, we need to enable flow logs to check the networking issues in AWS. Or if I talk about the storage service, we have EBS, various kinds of EBS options. Let's say if your application is having IO issues, how would you troubleshoot this? Right? If you have load balancer or auto scaling issues, how would you troubleshoot this? So we show you the demo of everything here. That is how we take it up. From the application side, yes, we do install application server, we do install web server, we do install database server, we do that. But I'm going to mostly show you things, what it is, what type of issues it comes from the cost optimization. Yeah, one important thing I missed to highlight. We talk from the cost optimization perspective. See, there are 5 pillars of good, well-architected framework. One is availability, reliability, performance, cost optimization, and security. So we touch base on 5 things on every topic. Every topic. See, it's going to be the cloud solution, but with cost optimization mindset. How do you optimally solve a problem? Let's say let's say if I ask you a question. 1 second, this is, we'll log in first. 7. So everybody would get this kind of a cloud. I'll guide you how to get this, and you would be logged into the, yeah, and we take AWS, friends, into us, like, we don't cover Azure and GCP, we cover on AWS. Just learn one, you can learn others. So everything would be cost optimized. Let's see if I talk about EC2, or let's say from the cost perspective, let's say you need to understand the workload. Are you going to deploy a core intensive workload or a memory optimized workload, or like core intensive, CPU intensive, or memory optimized? Your choice of instance type will vary. Right. Similarly, on the storage side, we have a lot of storage options. Let's say we have a lot of storage options here. When do you use which storage? We have EFS also, we have S3 also, we have Glacier also. So when do you use what service? So as a solution architect, what you're supposed to do? You are going to recommend what needs to be used. Right? That's what we prepare you for. So there are so many services in AWS. So we talk from that perspective. And once you understand this, you'll be able to understand how do we do troubleshooting. So first, understanding of the service is very important before you troubleshoot. So when I talk about the service, we do talk about what issues you will get and how do you go about troubleshooting it. For every service, from the cost perspective, from the performance perspective, from the availability perspective, from the reliability perspective, from the security perspective. We touch base on all the 5 aspects for every service. That's what this course is different, and that's how we take up things. You understand? You got your answer. Gokula Krishnan.
Yes, like sometimes you'll be sharing some of the examples, right? And like what type of errors can occur and how we can troubleshoot.
Definitely.
Okay.
See, first of all, I'll make your basics strong. Okay, first understand this. I want you to be crystal clear. What are you going to get? First of all, I am going to work on the basics. See, if you know cloud already, let's say, then you would be able to, you'll be excited about to know about the issues. But let's say if you don't know EC2, you don't know S3, you don't know EBS, or you don't know auto scaling group, you don't know load balancer, the basic stuff. Let's say you don't know. Would you be interested in knowing about the issues?
No.
Right? So that's what we do. So first of all, I'll make you comfortable. Then your mind will improve in thinking. You will be able to troubleshoot it better yourself. That's what we do. You understand?
Okay.
That's the approach. First of all, I'll make you. First of all, you should know what it is in detail. Right? Let's say um, I'll give you one example. You understood, right? Basically, let's say if you want to somebody wants to know performance testing. So first of all, they should know the basics, right? Why we are doing performance testing. There are other kinds of testing. Then what we do need to do, like we need to understand the workload simulation. We need to understand the load, right? When we do scripting, how do we do scripting? Now I cannot start with different kind of scripting issues. You understand, right?
Yes. Good.
I cannot start from there, but you're asking me that. So I cannot start from there. If I start from there, you'll get bored of what it is.
Okay.
So first of all, once you know these things, basics, you'll be able to think better.
Okay.
Okay, friends. Any other questions, friends?
How much duration it will be? Like how many days duration? Like that.
Yeah. So this, as I told you, right, this is going to take 3 months. It's a very exhaustive course. Okay, I'll
Okay.
show you. Okay, I'll show you. I'll show the live. So once you enroll, right, you will be added like this. Okay, I'll show you my WhatsApp group.
Yeah, already I have
This you
actually
have, you are part of which group?
no, not like this. I'm into the performance engineering. I'm taking this.
Okay,
If
you
I want,
know that, you know the process, right? So
yeah,
yes, you'll
I
be,
know.
so it will take basically 3 months. Okay, it's a very exhaustive course, 45 hours of live sessions, 4 hours a week. You can think like that.
Okay, got it.
Timings, which timings you can start?
Come again.
Timings.
This is the timing, IST timing. Yeah.
Yeah, as of now, my current schedule, right, engineering part, Satish is taking. So the particular session will be 8 to 9. So how can I cover this one as well? So that's what I'm worried about.
Do you want to continue with weekends batch? You can.
No. Actually, I'm interested this one only. So why? Because it will be weekdays. It will be very good, right? So might be it will complete around 1 week. It will be there. So 1 week after it will
Okay,
be.
1 week, right? So we'll go slow for 1 week. That's fine. You can complete there, then you can continue. We'll go slow. We'll share the recording. You need to put some efforts in the beginning.
Okay.
Anyway, from 9 o'clock, you'll be able to join here, right?
Right, exactly.
So half
That's
an
what.
hour, you can manage it for 1 week. I think that should not be a problem. Yeah.
Okay.
So I have a question. So
Hmm.
if I'm already aware of DevOps concepts, right? So I'll be redoing it here.
See, when
Right.
you said DevOps concept, you would be redoing means you know cloud, you know
Yeah.
Linux, you know Docker, Kubernetes, you know already all these things.
Yeah, because I took a DevOps course, so I
Mhm.
already know all the concepts, right? But I need only the SRE part here. So that's what I'm thinking. Because if I'm joining this course, I'll be redoing everything except the
Yeah,
SRE.
this may not be. See, if do you have Ramesh a troubleshooting background,
Yes, I have troubleshooting background.
like performance engineering troubleshooting, right? Yes. So if
That's
you have dev performance troubleshooting background and if you attended the DevOps course, then I think this
No,
may
like
not
what
be.
you highlighted, right? The SRE, yeah, these things I'm not aware. The
So
observability,
observability part, you mean to say?
yeah, troubleshooting and eliminating, and SRE, right? There's some SRE concepts too.
Yeah. So this terminology is, yes.
Yeah, so this is the thing I need to know. But if I join this course, I'll be redoing everything again.
Lot of
Except
things,
SRE.
lot of things, because we
Yeah,
focus lot of things time there. This comes at the last when we make the foundation, right? When we make the foundation, we start with these things.
this
Yeah.
is not a separate SRE course. This includes DevOps plus SRE.
Yeah, you can see both are, understand. See, we cannot, yeah, you have taken a DevOps course, so you can understand the like similarity, but you as an SRE engineer, we need to have DevOps skill as well. Like cloud, as I told you, right? Even performance engineer needs to have these skills. Cloud knowledge, Docker, Kubernetes. It's not about just the DevOps. Even performance engineer needs to have this skill. And SRE is an additional thing. So SRE is a combination of, I use this automation, which is the DevOps part, which you bring in the DevOps part. The automation, like when I said automation, I'm talking about the cell scripting, I'm talking about the Python scripting, I'm talking about the CI/CD pipeline automation, I'm talking about Terraform, I'm talking about Ansible, I'm talking about those things. So automation skills plus troubleshooting mindset. Troubleshooting, you'll be able to troubleshoot the application, plus deployment, Docker, Kubernetes, and different blue-green deployment. So when you combine, and plus security, when you combine this, you become an SRE. That's what we are trying to cover here. And we have a lot of services in AWS which will talk about security perspective. Um, so yeah, I understand your problem. Yes, you most of the things you already know. So yeah, in the beginning, you'll definitely get bored if you already know, and we'll be starting from scratch, because that's what I do. We do. I am going to assume that my audience doesn't know anything. Um,
Is
yeah,
there any separate course for this, like only SRE?
no,
Is
we
Isha
don't do
part of
that.
our combined?
We don't have such a separate course as such.
Okay.
I
See
missed
one
to.
chaos engineering. Will that cover SRE also?
You can cover that. Yes, that would be a better choice for you. I think that would be a better chaos engineering. We do cover, but I think ISA has a course chaos engineering separately. You might want to explore that. Even I'm trying to put it here. I have in my bucket list, I'll be putting my chaos engineering. I have giving you a lot of examples of chaos engineering. I have putting together. But I know that ISA Solutions has a chaos engineering course. You can check with Mr. Kumar, but I'll be covering chaos as part of this course as well. Yeah, I will be covering it
Okay, let me
along
check
with along with a
with
lot of AWS services, serverless services. I'm planning to cover. I keep
yeah.
enhancing this course. It's my baby. I keep enhancing this course. So I have designed personally from my experience. So I keep making efforts on this. Yeah.
And let me check with Kumar whether instead of joining the entire course, right? When you're teaching this observability troubleshooting, I can join. Let me check with Kumar about
Sure,
this.
sure, sure. Okay, friends, so that's all for today from my side. Um, Friends, I will tell you, it's going to be a very excited session, all those things, and a lot of learning. Okay, a lot of learning. If you are new to, let's say, if you don't know AWS, if you don't know Linux, if you don't know Docker, Kubernetes, if you don't know all these DevOps concepts like Terraform, Ansible, CI/CD pipeline, Jenkins, if you don't know all these things, I like cannot like stress enough that how much this course will help you. Enough, enormous. Okay, that's what I would say. Choice is yours. You can take a call. That's what I have been like. Uh, yeah,
What is the course fees?
you can check with Mr. Kumar. Fees and all. Check with Mr. Kumar. I'm going to talk about the course and the topics. Yeah, how
Okay.
we plan about it. Call this number. He'd be the right person to talk about the all those things.
Okay.
This is the number in the website. You have his number here. I'll share this link. Yeah. I have shared this link, and here is the number. You can get in touch with him. Okay, and I missed to mention, we give friends core Java. This is not my recording. Core Java programming, Python programming as part of this course. Okay, so we get this. So this is not my recording again, but somebody good at is Isha, full-fledged, like a lot of 30 hours of Python. Okay, and 30 hours of core Java. So programming. So you would get along with this course. But that's not my recording. I'll be honest about it, right? It's not my recording. I'll be taking care of other things. Yeah, go ahead. Somebody was asking some question.
Yeah, I was about to ask like who gonna if you got doubts in Python or something, so you gonna able to resolve or we need to
Python coding,
contact
I can resolve, but
yeah.
I'll keep you busy in cloud in so much that okay, you
Yes, yes.
not get time. But yes, I can answer your question. I can resolve this here, but you'll be very much occupied in my live sessions itself. Yeah.
So we're gonna take these recorded videos other than this 3 months or how it is like?
No, you'll be getting everything for the lifetime.
No, like we need to cover within these 3 months to know
It's
entire
up to
SRE.
you. Up to you. Oh, yeah, see, SRE, you see, you cannot become an SRE just in 3 months. Okay, you will.
Right.
This
Yeah.
this course will accelerate your learning. Okay, you need to put efforts. You need to put efforts, lot of time, more than what
True.
we cover in these 3 months. Uh, Additional 2 more months, like 4 hours daily. Definitely you'll become an SRE engineer. So that's what I would say. So not like that. You can cover later also. You can focus. See, at one point of time, you can focus on only one thing, right? If I ask you to
Exactly, right.
focus on, if I ask you to focus on Linux, focus on Linux. If I ask you to focus on a cloud, focus on cloud. Your entire attention should be here. And if you don't paying attention here and talking about Python, it will
Exactly, yeah.
you're not here, you're not there.
Clumsy.
So you will be in a mess. So because I'll be moving forward and you don't know the basics, then you'll stuck. You'll feel boring,
Yes,
which I don't want.
exactly.
So focus on one thing, whichever going on. Then you would, whenever let's say you're comfortable, okay, now I got what Roshan mentioned. Let me cover other things. So you can cover it.
Got you.
Sir, Chaos has Terraform also covered here in.
Correct. Terraform is covered here as part of this. Yes.
Okay.
We just give enough knowledge for you to do very good in Terraform. Okay, so look at the automation perspective, eliminating toil in automation. We cover Terraform, we cover Ansible, we cover CI/CD pipeline in Jenkins, and we do cover mundane stuff. I'm going to give you some 2025 Python scripting also, the most common used Python scripting, so that you can just answer in the interviews and you can do well.
So you will cover this Java and Python as well,
That's what I was telling, right? It's
Yeah.
a recorded session.
Videos.
It's a videos, self-paced. That's
Okay,
the
so you
only
will
thing I
provide
don't
these videos including in this package, right?
in this package. Yes, in the SRE thing. Yes.
And in performance testing bottleneck as well, correct?
Yeah. This will be given. This is my recorded session. This is my
Okay.
recorded session. This is my recorded session. Java performance engineering is my recorded session. I don't take it because if I take it, the class will go for 6 months. So I started not to take it, but you can ask me questions at any time. You would be getting it. You would be getting it. So you can get in the beginning itself. And look at the other playlist. I have this Java and Python programming one. This is the Java one. You get this much lot of. It's from the Isha, somebody right, good from Isha, Mike, and then Python is given by Abhishek. Again, very good. All the trainers are good, so you can full-fledged is what we are giving here. From scratch, they will talk about Java and Python. But this is not by recorded. Again, I'm telling you, don't get confused. Apart from Java and Python, everything is my recorded. Fine. Live session plus 2 are only recorded. Linux and Java. Performance engineering. Everything is live. 45 hours of live. This is gonna be my live sessions.
But this will be video you will provide, right?
Yeah. Yes, will be. You can ask me questions also in the session. It's a but this is my recordings. You can ask me questions also in the live sessions that, okay, you got stuck here. What is that? Or you can ask me your problem, whatever you are going through in your company. You can have a good discussion. You are having this issue, you're observing this, what to do, what not to do. I'll give you my perspective.
Yes. So actually, I have 7 years of experience in performance testing and engineering using Jmeter, plus some part of performance engineering part also, like monitoring tool New Relic I have used, and tuning part also we have covered, but little bit like according to our requirement in our company. So I just wanted to upgrade my skills in performance testing and engineering only. So this course, I guess, is beneficial for upgrading my skills and
That's
enhance.
what you are going to be cloud performance tester engineer, and that's what the requirement in today's market. That's why this course is for. This course is just like people like you. This course is designed so that to get benefited, because see, you know about the application, you know scripting, but what to do if this will be in the cloud, right? How would you troubleshoot it? Performance in cloud. Let's say if the application is deployed in Kubernetes, what type of capacity planning will you give? See, as a performance engineer, what we do, we test. First of all, we don't understand, like I have not telling about you personally, but what is your goal? Let's say as a performance tester or engineer, let's say the application is deployed in, let's say VM. Let's not talk about Kubernetes. In VM. So what we do, we need to understand the prod load, prod, what's the load, what is the prod infra required. So what we do, we test. Let's say prod load is 1000 TPS. We test with 100 TPS. And we do a capacity planning. Okay, for 100 TPS, first of all, do we have any performance issues? Like we have an SLA, response time, throughput, error, saturation, the CPU utilization, memory utilization. We have some SLA on these things. We make sure that we are meeting our requirement, the SLA. And if not, we need to work on the optimization, code optimization or query optimization. We can work with the developer on this. But let's say you are meeting the SLA and you got to know that for 100 TPS, you require 3 servers. So you now know for 1000 TPS what the server requirement, right? And you would be sizing it accordingly. Correct? Friends, all on the same page?
Yes.
But now let's say the things it is deployed in Kubernetes. What will you do? If you don't understand pods, if you don't understand pod capacity, if you don't understand auto scaling of pods, what would you recommend? You understand my problem? My question here. Maybe you may not be knowing what is pod, right? Kubernetes. That's the thing. It will be the case that it will be deployed in containerized application. What would you recommend there? Would you just tell, okay, I run with 100 TPS, we are getting error? No, look at the issues. That's what engineering is about. Look at the issues where the bottleneck is. Is it on infra? It is on application? It is on database? Where is the issues? Figure this out, right? So you need to have that understanding of the infrastructure, and that's where this containerization application knowledge of auto scaling in the cloud. If you talk about Flipkart, Amazon, right? So load on such websites are not consistent throughout the day. Right? In the night time, let's say when Indian sleep, all of us sleep, the load on a website is very less comparatively. But when we are in the evening on the weekends, the traffic is more. So servers needs to auto scale. So we talk about auto scaling in the cloud here. Right? How do you do auto scaling? How do you do load balancing? So if you look at the course, that's what we talk about in this course.
Will you explain like a live scenario as well, how we can debug the issue in the cloud as a performance?
Yeah, that's what we are discussing, right? That's what we do. Whenever I discuss a topic, I told you, right? We talk from the availability perspective, reliability perspective, security perspective, cost optimization perspective, right? And all these aspects. So we cover everything. That's what our detailed discussion is at a different level, which will help you in normal troubleshooting, even if you are not there. Yeah.
Okay. So live with the live scenarios as well, how like in company.
Everything is live. I'm going to show you load balancing. I'll show you auto scaling here. I'm going to live show you servers getting scaled out and scaled in. I'm going to create a load balancer here. I'm going to talk about a problem. I'm going to show you the metrics. Graphs, panels, I'll show you those things.
Yeah, yeah. Actually, if it is anything like migration happen, like on-premise to cloud, so those scenarios also it will cover, right?
I can talk about this, but we will not be able to do a live session on-prem versus cloud, right? I'll tell you what is the process, right?
Okay.
I'll talk about that, but I'm not able to show you how exactly we do that. I don't have those system on-prem and all. But when I explain, you'll understand most of the items.
Okay.
One is the database part is the challenging part. Apart from that, not a problem. A database migration, we have a service. We call it DMS. Okay, so we have a service. That's what we do. Everything is through service in the AWS. So I'll talk about this.
Yeah, so that's what even if they explain it is fine.
I'll tell you. Yeah. You are gonna get immensely benefited. I'm telling you. Okay, so yeah. So go over the link. Okay, go over the link and understand about the link. And if you have still questions, how are we planning about it? Please ask me tomorrow. Okay. So I have given the link. Go over the link, friends. Give a thought and ask me questions, more questions, which you have doubts about tomorrow. Or you can reach out to me in WhatsApp. You can reach out to anybody in Isha. They will help you with my number. I am available in WhatsApp. Okay, friends. So that's all for today from my side. Any other questions?
Yeah, we're good, Roshan, so far.
Perfect. Thank you so much, everyone.
Thank you all. Bye.
Thank you.
Thank you.
Thank you.